Today we're going to talk about graphing quadratic functions. Okay, so quadratic functions, they're also called a parabola. So often, and probably most often in this class, you'll hear me refer to them as parabolas. And a parabola can open upwards or downwards. And I think something that I didn't put in here, actually, as I'm thinking of it, is we know something's going to be a quadratic function if my x is squared. So this equation here is what we call like the parent function. So this is my normal or my parabola that has a vertex of 0, 0. It opens upward, and I can sort of show you how we would plot this a little bit later when we start learning how to graph these functions. But this we know is a quadratic because it's squared. So any function that has a squared term in it is going to be a quadratic function. If it's just y equals x, we know that that's a linear function. And the reason I'm saying this is because on the test, how do you know if you're going to graph a quadratic function or a linear function, right? And that's how we know. If the parabola opens upward, so you can see this red parabola, we say that the lowest, so it opens up, and at the very bottom, the lowest point is called the vertex. And the vertex is just if I drew a line through the vertex, which we call the axis of symmetry, sorry, that's a terrible straight line, this line through that vertex creates a line of symmetry, because if I take this parabola and I flip it, like fold it in half as I would like a piece of paper, if it was on a piece of paper, it's symmetric on both sides. And a parabola is always symmetric. And then if the parabola opens downward, like it does in the blue graph, we have our vertex being the highest point, or the maximum value. So we have a maximum value in this parabola up here of 1, 2, 3. So we have our vertex in this one is, right, if we said this was 1, 2, 3, etc., -1, -2, -3, -4, and this was 1, 2, 3, then this vertex is going to be an x value of 1 and a y value of 3. So my vertex is 1 and 3, and I have a maximum value. Now down here, my vertex is going to be -3 and 1, 2, 3 and -3, and it has a minimum value. And I always say when positive things happen, we smile. That's how we get the smile shape. And when we smile, we end up looking with this shape, right? Our mouth. And at the bottom is a minimum. And when bad things happen, we frown. When negative things happen, we frown. And then that gives me my maximum value. So you can always remember this as a picture. And if a parabola opened left or right, it would not be a function. But we're not going to look at that today. We're just going to specifically focus on graphing quadratic equations. So parabolas have a symmetric property to them, and that's what I just talked about. So when we draw this line of symmetry, just like like I did in the last example, except I drew a terrible line, we can draw the line down the middle of the parabola and we could fold it in half. And if we did that, it would be a symmetric thing. So we call this the line of symmetry, And we'll talk about how we calculate that in a little bit. Or if we graphed one side of the parabola, we could fold it and reflect it over the line. And some teachers use this form of graphing where we graph one half of the parabola and then we fold it over and we graph the symmetric half on the other half. That's not really the way that I tend to teach this, only because it's not as effective when graphing other functions. Well, you can't really use it on very many other functions, but it is a cool way to teach it as well, I guess, and maybe that's the way you've learned in the past, but we're going to stick to a little bit of a different method here, if it lets me turn my page. So we're going to start with what's called the vertex form of the equation. And the vertex form of the equation looks exactly like this top line here. So we have y equals a, x minus h squared plus k. Parabola. So the vertex in this equation is going to be h and k. So from this equation, it just means that whatever values here I pull down, that becomes my x value, except the opposite sign. So notice how this is a negative h here. So when I take my vertex, I flip the sign. So flip the sign. And I could explain why, because it's mapped inside of this x squared value. I could explain why, but just remember, you flip the sign when you pull it out of this bracket. This is exactly the same. We don't flip the sign of this one, and some students mix that up. So this, whatever, and I'll show you an example in a minute. Whatever this is becomes my y value, and whatever this is, we flip the sign and that becomes my x value of my vertex. Then the axis of symmetry is just going to be x equals whatever that h value is. So whatever my x value is, and I will show an example of that as well. So that's my vertex form. So if we remember from the last slide, so this being my vertex form, a x minus h squared plus k, this example, we can see, where's my pen? Oh, there we go. We can see in this example that it is in vertex form. I have an a term here. This would be my h term, and this would be my, what do we refer to? K. So the first thing we're going to look at is if I have an a value, so I don't know if I mentioned that. So I'm going to add this back to this slide. So if a is greater than, is greater than 0, then it opens upwards, because when positive things happen, so if this a value is a positive things make me smile. But if a is less than 0, so in other words, a negative number, when negative things happen, I don't know why this keeps happening, I'm sorry. When negative things happen, I frown. Oh my gosh. So this then opens downward. So when negative things happen, I frown, which is why I get that opening downward. And I'm sorry, I don't know why this tool is doing that. It's driving me nuts. Okay. So first thing we're going to look at is this value a positive or a negative? So this value in front of my bracket is positive. So a is greater than 0. It's a positive term, so that means my parabola opens up. So it's a upward facing parabola. And then to graph this function, we're going to first plot the vertex. So what is the vertex? Well, we just talked about that. The vertex is going to be whatever my h value is. So if I look in the bracket, it says -2, but remember, I'm going to flip that sign. So I'm going to put a 2. And then my k value, which is a 1. So I have 2 and 1 as my vertex. So this is my x and my y value, remember? So I'm going to go over, we're going to make these intervals of 2, or 1 rather. -1, -2, -3, -4. So first step, graph the vertex. So we have, I'm going to switch to a different color though. So my vertex is at 2 and 1. So there's my vertex. So now I'm going to draw my axis of symmetry. So my axis of symmetry, we sometimes say AOS, is going to be x equals whatever my x value is. So it just basically means the vertical line that runs through this x value. So that's going to be my axis of symmetry, x equals 2, axis of symmetry. And then we use this vertex to create our table of values. So we've done a table of values in the past. So my table of values is just going to be x and y. The reason I do my vertex first is because if I don't do my vertex, I risk, like let's say I just did -1, 0, and 1. Well, if I did that, I'm only going to get like the left half of this parabola. So I want to make sure I'm starting with the vertex so I get both sides of the parabola, so I actually get the point at which like it changes directions, or the symmetric part, like a nice symmetric parabola. So I start with my vertex and I'm just going to plop it in the middle here. So I'm going to get 2 and 1 as my vertex. Now I said here we use a vertex to create our table of values. We only actually need 3 points to create or draw a quadratic. Some teachers like you to do 5, but we really only need 3 points. So I'm going to pick a point to the left of my x value here. So the reason for that is because I have my vertex being at 2. So I'm going to pick 1. You could have also picked 0. Let's maybe pick a couple. Let's do 2, just so we get, but again, you only need 3, but just because for the sake of teaching here. So We have 2 and 1 as our vertex. So I'm going to pick 1 and 0 to the left, right? So 1, 0, and then to the right, because this is here, I'm going to pick 3 and 4. Now, it did end up being a nice 0, 1, 2, 3, 4, but sometimes it could be like 2 till 7 or whatever, right? It's going to depend on what kind of function you have. So how do I figure out what my y value is going to be? Well, that's going to require some calculations. So just like we did in our linear equations, I'm going to sub my x value in, so let's start with 0, into my original function up here, right? So this is my original function. Let's maybe erase some of the scribbles on this, because now it's just getting a little out of hand here. Okay, so we have 2 bracket x, so 0 minus 2 squared plus 1. So that gives me 2 times negative 2 squared plus 1. That gives me 2. And then negative 2 squared is 4 plus 1. So we are going to get a 9. So we might actually not be able to graph that one. So that's okay. That's a 9. Don't think my graph is big enough, but that's okay. That happens sometimes. And then we're going to do 1. So we're going to do the same thing, but for our 1. So we have 1 minus 2 squared plus 1. So that's going to be 2 times negative 1 squared. So that's going to be 1 times 2. So that's going to be a 3. So we have 1 and 3. I can plot 1 and 3. So 1, let's do it in red. Keep consistent here. Oops, 1 and 3. And then we're going to now do 3. So we have, I'm just going to, this is just stuff that you could do off to the side, like I'm doing on rough paper, right? Or you might just be able to throw it in your calculator and do it in 1. That's probably the easiest way, but whatever works for you. So I'm also going to get a 3 here. So, sorry, the arrows, there we go, there's 3. So now I have 3 and 3, so we're going to draw that point on my graph. And then 4 is also going to give me 9. So these should match up and these should match up. If they don't match up, then you've done math wrong somewhere, right? So it's always good to do as many as you can, and then if you have an error, then probably you'll catch it and you'll be able to graph it properly. So I can't remember if I have, no, I don't. Okay. Some of them I have the line drawn, so I don't have to do this, but let's try. Okay. So now all I'm going to do is I'm going to connect the lines as much of on a curve as I can. And the same thing like in linear equations, we do this arrow because this equation actually goes on forever. This isn't the end of my equation or my function, right? My function goes this way for infinite amount of time and this way for infinite amount of numbers. So we draw those arrows, but this would be an acceptable drawing of a quadratic function for this function. So y equals 2 in vertex form. So you'll notice we'll look at vertex form and then standard form. Each of those requires similar steps. The standard form just requires a little bit more legwork at the beginning. So let's look at another one. So now I have, often I'll have a fraction in front. So now I have negative 1/2 in front, x plus 3 squared plus 4. So to graph this function, we're going to first plot the vertex. So I have it written here, but how do we pull out the vertex? Well, we know our vertex is going to be this number, but opposite. So notice how that plus 3 now becomes a negative 3. In the last example, we turn back, that negative 2 became a positive 2, right? So we flip the sign of that one, and we don't flip the sign of my k or my y-intercept in this case. So or my y value of my vertex. So my vertex is at negative 3 and 4. So I drew a point there. I did this in advance. So 1, 2, 3, that's negative 3. And 1, 2, 3, 4, that's 4. And then we can draw our axis of symmetry, which I've drawn ahead of time because I knew it would be messy, through that. So our axis of symmetry is just x equals whatever that value was that we pulled out for h, right? So whatever this is. So x equals negative 3, that's my axis of symmetry. Now we can create our table of values just like we did, but we're just going to do 3 points this time. So I'm going to start with my vertex, negative 3 and 4. A point to the left of this would be negative 4. right? Because we're going in the number line, right? So we're going to do a -4, and then to the right is going to be -2. So we're looking at the number line is the easiest way to do this, because sometimes our brains can think of just random numbers to throw in there. But I'm going to pick -4 and -2. But now I have to calculate. So I have -1/2, -4 plus 3 squared plus 4. That gives me a 1 squared plus 4, so 1, so that gives me -1/2 plus 4, which gives me, oh, that's interesting. Is that supposed to happen? No, something weird. What did I do? I think I might have wrote something out wrong. Oh, this is not supposed to be a 4, first of all. But I don't think we're supposed to get 3.5. Oh, because I picked, oh, I should have picked -5. -5 would have given me a whole number, that's why. Anyway, that's okay. We can still do 4. I think I was just confused because I meant to pick. But that's good. I'm glad we did it this way, because we are going to sometimes end up with fractions. So we have -1/2 plus 4. So if you did this in your calculator, 4 take away a half is going to give you 3.5. So 3.5. I like to keep this as decimals just because it's kind of easier to think of decimals in our head. So I get a 3.5. And then I'm going to do the same thing with -2. I don't know why this keeps happening. I'm so sorry. I must be pressing a button, but I don't know how. So we get 1 squared plus 4. Oh my gosh. So I get -1/2 plus 4. So I get 3.5 again. So we have our -4 and 1, 2, 3.5. And then right here. And then I also went ahead and I guess I did 5. So if I plugged in a -5 here, let's try to do it up here. So -5 plus 3 squared plus 4, that's going to give me -1/2. -2 squared plus 4, that's going to give me, what did I do? So that's 4 times -2 is -4/2 plus 4, which is -2 plus 4, which is going to be 2. So I get -5 and 2. So that's where this point come from. And then I also did the same for -1. I also get 2. You can plug this whole thing into your calculator just using that exponent button and your fraction button, and it should be able to do this all for you. Some students, though, do like to do it by hand, and I'm pretty sure I actually have this parabola drawn much nicer than that. But I am glad that I picked one that isn't whole numbers. You sometimes will get fractions, and that's okay. You can still plot those. You're just going to go around halfway. And, it's not going to be exact because you are a person and not a computer, and that's okay. It's just showing your table of values, picking your vertex, and plotting at least 3 points to be able to graph the function. Okay, so next we'll look at when a function is in standard form. So standard form it looks like this. So y equals ax squared plus bx plus c. And you can notice here we don't have anything in brackets. We have an x squared and an x term, which is not what we had in the last one. But we still are looking at this value in front of the x squared term to know if our function is positive or negative. So same thing as in the vertex form. If a is greater than 0, it's positive, right? And that means it opens up. And then if a is less than 0, then it means it's negative, and that means it opens down. So same rules apply to standard form. Now, finding the vertex isn't as easy. So if you remember in our vertex form, we had, what did we say, ax minus h squared plus k, I think. our A term, we still have an A in this one, and that's how we determine if it opens up or down or positive or negative. But we don't have where we can just pluck our vertex out, right? So we just pulled this H out and this K, but we flip the sign. Well, it's not the same here. What we have to do is we actually have to calculate our equation of our line of symmetry and our vertex, okay? And the first step here is to use this equation, and this equation is a very important one to write down and to remember for when we have a quadratic function in standard form, is x is equal to negative b over 2a. This negative b comes from the number in front of the x, and the a comes from the number in front of the x squared. We don't end up using c. C is left for quadratic. We have another quadratic equation, but we won't be getting into that today or at all in this course, to be honest. So we just use x equals negative b over 2a, and that finds my line of symmetry or my x value of my vertex, right? Because I know that my line of symmetry is just the x value of my vertex. So let's try an example. We're going to find the line of symmetry for, oops, for this function. So let's write out my a is 3, right, because it's in front of my x squared term. My b is negative 18, and my c is 7. So we're going to use our formula. So our formula says negative b over 2a. And my b here is negative, but I have a double negative, so something to be careful of. So I already have, in this formula, there's a negative sitting outside of my b. So I'm going to already place the negative. I'm going to place whatever my v value is in brackets, and in this case it's a negative, 2 times my a value. So this becomes a positive 18 over 6, which becomes a 3. So then my axis of symmetry, oh my goodness, is x equals 3. And that's my axis of symmetry. Axis of symmetry, it's probably going to do it again, x is equal to 3. Now, to find the vertex, well, we have to find our line of symmetry, so we have to find our x value first. Then we can plug that into our original equation and find our y value, just like we do in the table of values. So at this point, we're getting pretty close to what we did in the last one. So let's find the line of symmetry first. Well, we know x is equal to negative b over 2a. So my a is negative 2, my b is 8, and my c is negative 3. So I have negative b, so negative 8, because we don't have another negative here, so it just stays as a negative 8. 2 times a, which is negative 2, so this becomes a negative 4 on the bottom. So we get negative 8 divided by negative 4 equals 2. So that's my x value. We're going to take this x value, we're going to sub it into my equation to find my y value. So my original equation, which is up here, we're going to put anywhere that there was an x. So there's an x here and an x here, we're going to plug it in. So we have negative 2 times 2 squared plus 8 times 2, take away 3. That gives me negative 2 times 4, blah, 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 which gives me this. And eventually, if you want to do it in steps, or you can plug it in right in your calculator all at once, we get y equals 5. So we have that the vertex is 2 and 5. So the 2 came from my formula, x equals negative b over 2a. My y came from me plugging that value into my equation. And this is exactly what you're going to do. So from here, our steps are the same as what we did in the vertex form. In the vertex form, we plucked the vertex right out of the equation. Then we put that in the middle of our table of values, picked a point to the left and to the right. So now we found our vertex, and we're just going to follow the same steps as we did. So the only difference is we had to find our line of symmetry. So our line of symmetry is negative b over 2a, and our vertex is going to be, we plug that in, and we find our y value. Then from there, we're going to use the vertex to pick a point to the left and right, same thing as we did in the other form. We use this to create our table of values, and we plot our points on the curve. So the only thing that's different here is we actually have to calculate our vertex. So let's look at one. So this is in in standard form because I have an x squared, an x, and a number. So let's find our line of symmetry. A is equal to 2, b is equal to negative 4, c is equal to negative 1. And I don't even need to write c down, but I just am for consistency. This is my formula for my axis of symmetry, or my x value of my vertex. So I have negative, but my b is already a negative, so I have negative, negative 4, right? So just be really careful when you have a negative sign with your b, not to miss that. 2 times a, so that gives me positive 4 over 4, which gives me 1. So my line of symmetry is x equals 1, so it goes right through that 1 value. That's also my x value of my vertex, right? So now I've solved for part of my vertex, but I don't know what this is. So the next step, I hope I didn't go too fast there. I guess you're not writing it down, you're just following anyways. Okay. Next step is to find the vertex. Well, I've already found that my line of symmetry is x equals 1, so I know that my vertex is 1, but let's figure out what is y. We're going to sub this into our equation. So I have a 1 squared minus 4 times 1. So again, this is just this equation that I started with, my original quadratic function, and I'm subbing in my x value that I found. So we get 2 minus 4 minus 1, which gives me 2 minus 4 is negative 2, so negative 3. So my vertex is at negative 1, sorry, not a negative 1, 1 and negative 3. So you can see I've drawn it here. So at 1 and negative 3, this is my vertex. So on the test and also your assignment, you'll probably be asked to find to identify the axis of symmetry. You might have to be asked to find if it points upward or downward. So does this point up or down? Like, is this upward facing or downward? Well, we know whatever number is attached to my x squared, which is my a value. If it's positive, positive things make me smile. If it's negative, negative things make me sad. So it's a positive thing, which means it's upward facing. Its axis of symmetry is x equals 1. Its vertex is 1 and negative 3. And then you're also probably going to be asked to also graph the equation. So that's why we do it in these steps. So we found our vertex to be 1 and negative 3. So we're going to use this to create my table of values. So a point to the left is 0, and a point to the right, we're going to use 2. So let's start with 0. Just going to sub that back into the equation just like we did a minute ago. We're going to sub it into this equation and find our y value. So we get 0 minus 0, so we get negative 1. Then we're going to get 2 times 2 squared minus 4 times 2 is 1. So that gives me 2 times 4 minus 8 minus 1. 8 minus 8 minus 1, which gives me negative 1. And that is good because these should both be the same. But I always like to do it just to make sure. Oopsies. So we have, now we're going to draw our points. I thought I did that, but I did not. Okay, so we have at 0, we're at negative 1. And at 2, we're at negative 1. And we can draw that parabola. Whoopsies, sorry, I missed that line completely, but you see what I mean. It's much easier to do on a piece of paper and not on a computer. That is going to be my equation of my parabola, or my graph of my equation of my parabola. Okay. Oh, and that's the end.